Okay, so before we get started with the lab, let's just find out what an SQL injection is, what it means, and how you would typically use it. So an SQL injection is a code injection technique used to attack data-driven applications in which malicious SQL statements are inserted into an entry field for execution. For example, to dump the database contents to the attacker. A SQL injection must exploit a security vulnerability in an application software, for example, when a user input is either incorrectly filtered or for string literal scope characters embedded in SQL statements, and even user input if it's not strongly typed and unexpectedly executed. So SQL injections is mostly known as an attack vector for websites, but can be used as an attack on any type of SQL database. SQL injections is a hacking technique which attempts to pass SQL commands or statements through a web application for execution by the back-end database. If it is not sanitized properly, web applications may result in SQL injection attacks that allow hackers to view information from the database and or even wipe that content, right? So we have various different types of SQL injection types and attacks. So we can classify SQL injections into three major categories: inbound SQL, inferential SQL, or out-of-band SQL. So an inbound Sqli or an inbound SQL injection is the most common and easy to exploit out of SQL injection attacks. Inbound SQL injection occurs when an attacker is able to use the same communication channel to both launch the attack and then gather results. The two most common types of inbound SQL injections are error-based and union-based SQL injections. Error-based SQL injections is an inbound SQL injection technique that relies on error messages thrown by the database server to obtain information about the structure of the database. In some cases, error-based SQL injection alone is enough for an attacker to enumerate an entire database. While errors are very useful during the development phase of a web application, they should be disabled on a live site or logged to a file with restricted access instead. Union-based SQL injections. A union-based SQL injection is an inbound SQL injection technique that leverages the union SQL operator to combine the results of two or more select statements into a single result, which is then returned to as part of the HTTP response. Okay. Then we have another major category called inferential SQL injections. These are typically blind SQL injections. An inferential SQL injection, unlike an inbound SQL injection, may take longer for an attacker to exploit. However, it is just as dangerous as any other form of SQL injection. An inferential SQL injection attack, where no data is actually transferred via the web application and the attacker would not be able to see the result of the attack, which is why such attacks are commonly referred to as blind SQL injection attacks. Instead, an attacker is able to reconstruct the database structure by sending payloads, observing the web application's response, and resulting behavior of the database server. There are two types of inferential SQL injections, and they are blind Boolean-based SQL injections and blind time-based SQL injections. Boolean-based or content-based blind SQL injections are inferential SQL injection techniques that rely on sending an SQL query to the database, which forces the application to return a different result, depending on whether the query returns a true or a false result. Depending on the result, the content within the HTTP response will change or remain the same. This allows an attacker to infer the payload used returning a true or a false, even though no data from the database is returned. This attack typically will slow down, especially on large databases, since an attacker would need to enumerate a database character by character. So the attack would take a lot longer than other types of SQL injection attacks. And then we have the time-based blind SQL injection. So a time-based SQL injection is an inferential SQL injection technique that relies on sending an SQL query to the database, which then forces the database to wait for a specified amount of time, and this is generally in seconds, before responding. The response time will indicate to the attacker whether the result of the query is true or false. Depending on the result, an HTTP response will be returned with a delay or returned immediately. This allows an attacker to infer if the payload used returned true or false, even though no data from the database was returned. So same as the previous one. This attack is typically slow, especially on large databases as well, since an attacker would need to enumerate databases character by character. And then finally, we have the third major category called out-of-band SQL injections. So And then finally, we have the third major category of SQL injections, the out-of-band SQL injection. This is not a very common SQL injection type, mostly because it depends on features being enabled on the database server being used by the web application. Out-of-band SQL injections occur when an attacker is unable to use the same channel to launch the attack and gather results. Out-of-band techniques offer an attacker an alternative or inferential time-based technique. So especially if the server responses are not very stable, making an inferential time-based attack unreliable, right? So out-of-band SQL injection techniques would then rely on the database's server ability to make DNS or HTTP requests to deliver data to the attacker. Such is the case with the Microsoft SQL Server xp_dirt_tree command or dir tree command, which can be used to make DNS requests to a server and attacker controls. So as well as Oracle bases where they use the UTL_HTTP package, which can be used to send HTTP requests from the SQL and PL/SQL to a server and attacker controls. So before we get into all the nitty-gritties, I want to go through a couple of definitions. The first one being spidering. So spidering is a technique of mapping a website and identifying all the pages accessible to a user. This can be done in two ways. It can be done actively, and this is when the tool being used will click on every single link and button and fill in all the form fields. The tool will continue to complete all of this information unless instructed to stop by the user initiating the spider or crawling. This can be dangerous because it can be seen as an attack if the tool was to find an admin page and submits buttons to delete users or pages on the administrative console. There is also a different method called passive spidering. This is where the spider will act like an active spider but will stop at the next page when it gets there. This tends to be safer than an active spider. This should be done prior to testing for any vulnerabilities on a web application because it can give you the full structure of the web pages. It will also identify any pages that should not be accessible by the end users. So next up, let's go ahead and configure Burp Suite. We're going to open up our browser. First of all, we're going to see, so I've already done this, and I'm going to tell you why the proxy server is refusing the connection. Let's go to our preferences, advanced network settings, and then you'll see that I've configured the manual proxy configuration to 127.0.0.1 on port 8080. You'll see that there is a local host and 127.0.0.1 field over here. You have to take this out. Right, so if we go ahead and open up Burp Suite, and I'm going to show you what's happening and why this connection has been refused to our local exploit target. By the way, this is the web app for pen testers 2, which I'm going to be using for these demonstrations for the time being. So go ahead and leave these old temporary files. We can see that there is a update now. Let's just go ahead and click on update. And it's going to say the proxy server is refusing connections. Okay, so for this, we are going to disable the proxy for now, right? So let's say no proxy. Click on OK. Refresh. And you'll see that it actually works. Okay, so the reason for this is that if you intercept the traffic, we need to accept the connections within Burp Suite, right? So if you have anything where no proxy is configured, you want to do the downloads for the updates or the updates for Burp Suite, then you need to go and disable your proxy. For now, I'm not going to do this update. I'm going to go back to my advanced network settings, and I'm going to use the manual proxy configuration. Right. I'm going to go ahead and close this. Okay. And then what I'm going to do is I'm going to continue with a temporary project. We're going to use the burp defaults, start Burp Suite. And it's going to start up a project. Okay, and this is what the Burp Suite interface would look like, right? So the next thing that you're going to want to do is get the Ssl Certificate or the signed CA from Portswigger onto your browser. I've already done this, but I'm going to show you how to do it as well. So you go ahead to http://burp, right? And then you'll see Burp Suite Free Edition. You can go ahead to the right. You can click on CA Certificate. it's going to save a file, which you can then go and click on. And then you can see the details of this. You can go ahead and click on import. You're going to have to type in your password, and you're going to sign or save the port trigger CA. I'm not going to go and click on OK because I've already done this. This is just so that you can intercept HTTPS traffic, right? Because without this, essentially Burp Suite is acting as a man in the middle, and any HTTPS traffic you will want to intercept as well. So you'll have to have the signed certificate from the CA in order to intercept that kind of traffic. Another way that we can configure Burp Suite to temporarily stop intercepting traffic is if we go to, let's just show you the example again. So this is my local server, which is currently being intercepted. When I go to the Burp Suite project and I see that Proxy is highlighted, we can see that there are GET requests going through. So this is because the interception is on. What you want to do is you want to turn intercept off, and it will load. So the next thing I'm going to want to talk about is the way that Burp Suite actually handles the requests, and I'm going to show you how this works. I'm going to turn the interception on again. I'm going to reload the page, and then we can see that we have raw packet information. So in this case, we've got the GET request. You can actually go and manually change this information if you wish to do so. So I'm going to show you how that works later as well. And where this is useful is when you actually have cookies and you want to change the cookie information for a cross-site scripting attack, those kinds of things, which we'll also discuss a bit later. And so the next thing I'm going to want to talk about is the target. So go ahead and click on the target. We can see that the passive spidering has already been done. You can see when you browse to the host, the different folders that have been identified. For example, in the SQLi, it's example 1, example 2. You can go, if you browse around, so for example, the XML attacks, go back to your proxy, forward, then we'll see underneath the target that XML should have been populated as well, example 1 and example 2. So you can do this actively and as well as passively. If you browse through the entire application, you'll see the full directory structure over here as well. So next up, we're going to use the OWASP ZAP proxy. So what I want to do is what you have to do is you have to close down Burp Suite, otherwise it's going to interfere with the OWASP ZAP tool. So I've already done this. You'll see that if you refresh the page after closing down Burp Suite, that it's going to say Proxy is refusing connections. The way you fix this is going to your preferences. You can go out to advanced network settings, and then you can just go and say no proxy, use system proxy settings or auto detect proxy settings for this network, and it will fix the issue, but I'm not going to do this for now. So first off, let's just close some of this. Let's close that as well. And let's browse to our applications. We can go to Web Application Analysis, and then we'll go to the OWASP Z proxy or Z application proxy or OWASP ZAP. So for now, let's just see. Okay, cool. So this thing is going to load. It will ask you to accept terms and conditions if it's the first time that you open OWASP ZAP. I've already opened up OWASP ZAP on this instance. So I'm going to wait for it to load. While this is loading, let's go ahead and copy our IP address for the victim machine that we're targeting. So once this pops up in OWASP ZAP, just say no, I don't want to persist this session at this moment in time, and you can go and click on start. So now always check for updates and start, so you can do this if you want. I'm just going to say okay. So what I want to show you first is the ability to do passive scanning. Let's just close this. If I go and refresh the page, it's going to open up the web app for pen testers, and we'll see some form of history displayed here at the bottom. If I go to the browser and click on a couple of different links, you'll see that this will update as well. So let me just make this a bit smaller so that you can see, put them side by side. You'll see that there are new things popping up every time we click on a link. So this is like passive scanning, the same type of thing we did in Burp Suite. So for now, what I will want to do is we're going to take this out. and put our target host in, but do not click on attack yet. So I want to show you something else first. If you go to the left hand side where you can see sites, you'll see that the target host is actually in here with the passive scanning that we've done so far. So you can go ahead and minimize that. What I want to show you though is I want to show you if you click on attack and we go to spider, click on this, it's going to open up a target point so we can see our target. We're going to recurse to open up new pages once the scan has completed the page that it's been on. So remember, it clicks on buttons, it clicks on links, etc. And then also you can show advanced options where you can go and configure some other things if you want to do this. But for this scan, we're going to leave this in default. So go to scope and set start scan. So now you'll see it's going to do a crawl of the web application, and we'll be able to see the history of this. And you can see that it's mapped out the entire web application for us, right? So now we can see the full directory structure. So if you go and browse into all of these different folders, you'll be able to see. So next up, we're going to scan for vulnerabilities related to SQL injections. We're going to verify that we can still access our web server, and this is true because we can browse to it. The tool we're using is Vega, but it does not come with the latest release of Kali Linux. So we're going to do an apt-get install Vega, and then you'll see that it is going to download the tool for us. This might take some time, so what I'm going to do is I'm going to pause the video until Vega has downloaded or until the next step is required and show you what to do after that. Okay, so once Vega has successfully downloaded, type into your terminal Vega. It's going to open up the tool. Okay, so now we're presented with the Vega interface. What we're going to want to do is we're going to want to configure our scan so that we can scan the web application for only SQL injection related vulnerabilities. So let's go ahead and start a new scan. Okay, so let's take the target address, paste it in there. We're going to say next. So here we can see all the different injection modules which we can configure for this. I'm going to go ahead and deselect everything related, not related to SQL injections. So let's go ahead and do this. Shell injections. Okay, let's take all of this out. Put these blind SQL injections in. Let's take this out. Okay, we're going to take this out as well. So there are a couple of ones you're going to want to deselect. Okay, once you've done that, go ahead and click on next. So you can configure the identity to scan the site as, but you'll have to do this in the configuration options. In this case, we're not going to scan as a credentialed user. This is you'll only use this when you have credentials to the site, right? You can also add cookies, but in this case, we're not going to do it. And here is where you would exclude any parameters. So if you know that your web application is prone to break due to certain arguments, you can go and take these out, click on remove. But we know this thing can handle our scans, right? So let's go ahead and click on finish. And now you can see that it's actually starting the process for scanning. So one thing that you should note is here under the website view, it is doing a crawl on the target, so 192.168.55.139, but it's also trying to crawl other websites associated to this or that you might have seen on this web application, but we can see that they're grayed out because it wasn't able to successfully spider them. Okay, so this is also where you need to be very, very careful, because if this is something that is not associated to you or your organization or the customer that you would be scanning, they might see this as an attack. So you'd really want to be very careful about what pops up over here what is actually being scanned. So the same as Burp Suite, and OWASP proxy, the ZAP proxy, you'll see that there is actually a crawl being done, and it'll show you all the different directories included into the web server. So it does something similar to that as well. And it's also going to start scanning for vulnerabilities, but this might take a while. So what I'm going to do is I'm going to pause the video again, and once this is done, we're going to go through the results, and I'll show you what to look out for. Right, so our scan is finished, but I see that there is a bit of an issue. I seem to have included some modules that did search for cross-site scripting and Ssl Injection, but that's not the end of the world, since we can still go and drill down into our application and see SQL injection related URLs. Okay, so these URLs are all, we know that they are vulnerable to SQL injections because that is the way that this application has actually been designed. It has been designed for us to be able to do SQL injections on the application, right? So what we can do is when we go to our examples, we can see the information about the SQL injection at a glance. So we can see which URL has been affected, the parameter which was affected, the method that was affected, the detection type, so a blind arithmetic evaluation differential. We can see the risk associated to this. We actually see the exact request being made. So with these parentheses, which we will talk about a bit later, we can see the resource content, so which was affected. We can see a little bit of information around the specific type of vulnerability, the impact of this vulnerability, the remediation efforts that need to be taken place, and then we have some references as well. So this is quite cool for the reporting phase of any penetration test. So you can include this into your report and easily copy and paste this, and then you can give it to the person you're doing the pen test or vulnerability assessment for, rather, because this is more vulnerability assessment side. Pen test would be to use case and showcase that you can actually exploit the vulnerabilities, but then you can give this to him in an effort to remediate certain vulnerabilities. The next tool I want to show you associated to SQL injections, discovery of them and exploitation of them, is a tool called SQL Map. So I'm going to go ahead and close this for now. Okay, so if we go ahead and browse, or let's just click this workspace first, and we say man SQL map, then we'll be able to see some information related to the tool, right? So you'll see things, if we browse down a bit, so some important things that we might want to look for is things like the risk, the levels, U for URL forms. Let's just see here, just browse down a bit. There are many options related to this tool, right? Okay, so level is one of the important ones. So this is the level of test to perform, so 1 to 5. 1 is the default, 5 is the most. You know what I'm going to do? Rather, I'm just going to close this down because there are a ton of options that we might not want to, which are important, but we're not going to go through them in this course. Okay, so I'm going to go ahead and open up a nano file and then SQL map. Okay, so let's just go and go through some of the important features. So there's a -u, which will be for the input of the URL. We'll have a -forms, which will be for parsing and testing of forms. Then we'll have a batch, -batch. Let me just make this proper. -batch. So this will be for non-interactive mode. So usually what happens is SQL map will ask you for questions, and then this will accept the default answers for that, right? So then you don't have to manually intervene the tool. Then we have a -crawl. Okay, so this will mean how deep are we actually going to scan. or crawl the site. And then we will have a minus level. So this will be different levels of tests. So we have 1 through 5, 1 being the default, 5 being the most. And then as well we have risk. So minus risk. And then this will be different risks or risk tests. So we have options from 1 to 3, where 1 is the default, and then 3 will be the most. Right, so next up, let's draft our query that we're going to use for SQL map. I'm going to type in SQL map, and then we're going to say -u with the IP address that we want to attack, so the victim host. Take out the HTTP header. Then what we're going to do is we're going to say --forms. We're going to say --batch to accept default answers, so we don't have to manually intervene. We're going to set our crawling level, so crawl equals 1, and then we're going to set our level to equals 5, and we're going to set our risk to 3. Okay, so then we're going to start the scan. This might take some time to complete. I'm going to get back to the video in a couple of seconds. Okay, so now that the scan has finished, we can make this a little bit bigger so that you guys can see it. So it says that we do have SQL injection vulnerabilities detected against the host 192.168.55.139. So we've automatically skipped most of the process as well, but we can see some information around where these vulnerable applications are sitting, or where these SQL injections will be found. And you can actually see some database information which will be useful a bit later as well. And the cool thing is that this tool will actually export the results into a CSV file so that you can view later. So what I will do is I will nano into the file that it generated, and you can take this as an easy reference once you want to start exploiting certain hosts, right? So I'm just going to make a backup of this as well, and then just save it on my desktop. Just paste that in and then save it. And now we'll have this on our desktop for a later reference as well. So next up, we're going to use the Nmap scanner or network mapper, which can also be used as a vulnerability scanner when using the NSE scripts that you get with Nmap, right? So the scan that we're going to run will be Nmap -p for port. We're going to use port 80. We're going to call a script which is equal to HTTP SQL Injection, and then we're going to pass some arguments. So script args equals HTTP spider, which says that we're going to use the crawler, and set the max page count to 200, and then we need to specify the target. So take out everything except for the IP address. Okay, and that should start the script. Okay, so that was quite fast. Let's have a look at the results. So again, we can see port 80 is open on HTTP. The HTTP SQL injection script says there are possible SQL injections for the following queries. So these are the results that Nmap has found, quite similar to the other tools as well. I'm just going to make a note of this, and then we can reference this a bit later. So we can see the URL and also what script was executed, right? So let's go and put this into our Sqli text folder or file. Let's just make a note of this and say Nmap. Put that over there, and over here we'll just say SQL mapper, and we'll click on save. Okay. One thing that you do have to note around these Nmap scans, or this Nmap scan in particular though, is that these won't be the direct links to the vulnerable SQL injections. So these are seen or deemed as possible SQL injections, right? So SQL queries. And it will show us that we have various SQL vulnerabilities on the different links, on the different sites, if you want to call them that. But it doesn't mean that these will actually work, right? So that's why it's very important to use multiple tools when you are doing a pen test or vulnerability assessment, so that you can confirm whether the vulnerabilities will actually exist. So in this particular case, if Nmap was set up differently, we might have had different results, but this might not mean that these are going to work. And on a different host, the Nmap might actually, provide better results and the real links for the SQL injections. Okay, so next up, go back to your OWASP Z-attack proxy or ZAP. Now we're going to actually run an attack against this host, right? So you can go ahead and if your IP address is still in here, you can say attack. And it's going to actually start the attack. If there is anything that the spider has missed, it's going to crawl through that now. And you can also go and see all of the different URLs that was picked up, and you can manually go and verify whether all of these are the right ones for the application that you're attacking specifically, right? So let's go to our active scan. We can see that it's doing scans against various URLs, and we're getting 200 OKs, 404 not found, moved permanently. As we discussed in the beginning of the course, you should know what those mean. What you can also do is you can actually go and you can edit policies, right? So what will happen is, let's just go and change, let's just see, where is this view, analyze, scan policy manager. So we've got the default policy selected now. You can add a new policy if you wish to do so. You can modify this existing policy as well. So you can see there's various different things that we can do, such as alerts. You can check your client browser information gathering, where we do directory browsing. Our injections. So what we actually want to test for is SQL injection. And you can actually go and turn off all of these if you wish to do so, which I would recommend that you do anyway. Because if you have everything scanning all at once on a web server that you're testing for one of your customers, you could actually make the server fall over, right? So you also have some strength options which you can change if you want to go for insane strength or low defaults, quality. You can change this. Miscellaneous, you'll have the external redirect, script active scan rules, and then server security, so path traversals and RFIs. So let's just go ahead and click on OK, and we'll click on close. And we can see that the scan is going to run. It's going to run for a while. So OWASP Z proxy, Z-attack proxy is also a very cool tool. It's free, and I would recommend you add this to your arsenal as well. And then you can also go and generate reports, right? So you can generate HTML reports, XML reports, Markdown, so a response to file, all URLs to the file. So you can do quite a bit with this tool as well. And the fact that it's free makes it a lot cooler, than many of the other tools as well. And when you think about it as a vulnerability scanning solution, this is I think my personal opinion is that it would be much better than an Akinetics or a NetSparker, for example, as well, because you have all the functionality that those tools provide you, and you have this at no cost. So we can also go and view some of the results that we've found while this thing is scanning. So you can head over to the Alerts tab, and then you can go and have a look at the SQL injection. So what's cool about this is it gives you the URL and also risk scores, associated description, and you've got some other information as well which you can drill down into. But yeah, once all these results start populating, you can go and test out these vulnerabilities. I'll show you how to test them out as well. But yeah, that gives you some cool information around the SQL injections that it could possibly pick up. But we know these SQL injections exist. So an interesting one, for example, is that it will give you this attack parameter, where after the root you'll type in and then you'll type the 1 equals 1, the traditional 1 equals 1 statement, and you'll be able to actually exploit that. So we're going to test that out a bit later, but I'll show you why this is relevant as well. Now we're going to try and exploit the SQL injection manually. We are going to click on the example 1 for the first SQL injection. So we're presented with this at first. We know that the root parameter is vulnerable, so we're going to take that out. We're going to do a single quote or single quote 1 single quote, and then we're going to say equals single quote 1. And this will show us the IDs, names, so these are usernames of various different users. Okay, so now that we've seen how we can test a parameter whether it's vulnerable, there are a lot of different methods in which you can actually go and query the SQL database, where you can type in different queries which will give you information around which fields would be vulnerable, which fields could be modified, those kinds of things. But what we're going to do is we're going to use an automated tool that will do that for us, because the time it takes to identify those types of fields could take very long. Even though it could be beneficial if you are doing it that way, due to the automated tool causing a lot more noise than a manual test would. But for this example, let's just use SQL map, which we will use to exploit our host, our SQL injections. So we're going to type in our vulnerable host's IP address. Let's just go and copy it again. You can go ahead and paste it in. You can leave the HTTP section in this. And then we're going to do --- dbs. Oops, okay. So you can't just use SQL map in the way we just did. Let me show you what I mean. So we need a vulnerable parameter to test against, right? So let's go back to our web application. This is a good example of a vulnerable. We know that this parameter is vulnerable, so let's just throw that into SQL map. Just type the up arrow, take the previous result out, and paste it back in, and let's see what happens this time. Let's just type yes, and type yes, yes again. Okay, so we can actually see something came back to us where we can see the version of SQL, so it's MySQL. We can see that we used a union query, the payload, and then we can also see the web server operating system. We can see the application technology, PHP and Apache, and some backend information. It was able to extract two databases, the exercises and information scheme. And it was able to fetch a data, so the fetch data was actually logged to a text file that you can go and find here, so like we saw previously. So the next step that we want to look at is we want to extract the tables, right? So I'm going to go for the first query where we had example 1. We are going to take out the -dbs, and we're going to replace it with tables, and then we are going to put in a -d, and we're going to go for not underscore d, -d, where we can specify the table that we want to take. And in my case, I'm going to take the exercises. Right, so we can see that the database exercises has one table, which is users, You can see that over here, and the scan has finished quite quickly. So next up, we're going to want to extract the columns. So I replaced this parameter with columns, and then I added the table users to our extension or to our query. Let's go ahead and see what happens. Okay, so now we can see the column. We have age, group ID, ID name, password, and then we also have the types associated to that. So the most interesting part out of this is the password column. And of course, what we will want to do is we are going to want to dump those users' passwords, right? So what we'll do is we'll go up again and we'll change the columns to a -- dump, and then we'll have our table of exercises. We'll have our users, and then we'll just run this. This should work. Nope. Okay, so let's just have a look at our command. Okay, so dump has to be lowercase. And now what we can see is we can see our user IDs, group IDs, the username admin and the password admin. We can see the root account and his password associated to him, and various users. He created a password secret and a Xerti.